QA technology is globally recognized for exceptional product performance, competitive prices, fast delivery, and outstanding services. A spring test probe is typically designed to be used at its working stroke, which is typically 2/3 of its full stroke capability when testing its target. With this in mind, test fixtures should be designed and built so that the sockets, or X-probe termination pins, are set at the correct height for the probes to stroke at the recommended amount when actuated by the unit under test, or UUT. Set too low, the spring force may be insufficient for a reliable electrical contact to the UUT. Set too high, the plunger will be overstroked. This causes early spring fatigue, tip damage, or other premature probe failures. Setting probes at the proper working stroke will achieve the highest first pass yields, maximize probe life, and reduce overall maintenance costs. You can easily measure how much a probe will be actuated during test by using QA's indicator probes. Indicator probes are not intended to be used as electrical contacts, but are designed to travel with the fixture as it's actuated and remain compressed at the test position. Indents on the side of the indicator probe tube interfere with the free motion of the plunger, and its deflected position is maintained. The plunger of an indicator probe is unplated, making it easy to identify. Indicator probes are available in both headed and headless versions. Always use a headless indicator probe when the fixture support plate has a guided probe feature built in, which uses a small plunger clearance hole. Before installing indicator probes in a fixture, remove the support plate and decide where you want to measure the actual stroke of the probes. To get a good indication of the overall probe stroke, it's common to measure at each corner of the probe field, along with one in the center. It's best to select a headless probe location that will measure the stroke of probes hitting vias or test pads. However, if necessary, you can use a location that will test a lead or post. To begin, we need to know the height of the existing probes in the fixture. Handheld calipers are perfect for this. Measure from the top of the probe plate surface to the tips of the standard unactuated probes at each location where indicator probes will be used. Capture these measurements and save for later. This will be used as dimension A. Now you can remove these standard probes from their sockets at each of the 5 selected locations. Install an indicator probe into each of the sockets or X-probe termination and press down as far as it will go. The plunger will stick down. Using tweezers or needle nose pliers, pull up on the indicator probe plunger, bringing it back up to its original position. Be careful not to pull the probe out of the socket. Repeat for each of the locations to be measured. Now the indicator probes are in position and ready to be actuated. Reassemble the fixture by installing the support plate. Then place the UUT onto the fixture and cycle it one time only. The indicator probe plunger will remain deflected, showing its position when the fixture is actuated. Remove the UUT and guide plate. Measure from the probe plate surface to one of the actuated indicator probe tips. This will be used as dimension B in the calculation. Repeat at each indicator probe location to ensure that all probes across the entire field are stroked a similar amount. Compare the difference in height between the original test probe and the indicator probe. This is the amount of plunger stroke that occurs when the fixture is actuated while in production. Compare the actual plunger stroke findings to the working stroke number for that particular probe series. Again, this is typically 2/3 of the full stroke capability. If probes are being understroked, sockets or termination pins may need to be replaced at a higher set height to achieve the proper stroke. If probes are being overstroked, sockets or termination pins should be lowered to correct the situation. Finally, remove the indicator probes at each location and replace with the original probes in the fixture. Reassemble the support plate back onto the fixture. Now, you're ready to use the fixture. Please note that an indicator probe will lose its ability to remain in the deflected position after several uses and should be discarded. In summary, Spring test probes are made to be at their designed working stroke when testing an intended target. The working stroke is typically 2/3 of a probe's full stroke capability. Test fixtures should be designed and built so that the sockets or X-probe termination pins are set at the correct height for the probes to stroke the recommended amount when actuated. Setting probes to achieve the proper stroke will increase first pass yields, reduce fixture maintenance costs, and improve the performance and longevity of your test probes. For more information, contact us or visit qatech.com.